Hi.
Hi.
I'm a research faculty here, and so my main job is, first slide will pop up here, but I'm the co-PI on the Antarctic Search for Meteorites program. And along with my other co-PI, we're basically in charge of collecting or searching for and recovering meteorites from Antarctica. There's an image of Antarctica there, a mosaic of a radar sat imagery, and you can see that it's covered with ice. Antarctica is covered with ice. There's land on there, but there's a lot of ice there. It's a great place to search for meteorites because there's a concentration mechanism that's unlike any on Earth. And that's, if you look at Antarctica and the topography of it, it's basically an overturned bowl with the highest points kind of right at the South Pole. So the ice sheet and the glaciers are basically flowing out to the edges of the continent over the last, say, 30 million years. Over those 30 million years, meteorites have been raining down on the ice surface, being covered, incorporated into those ice sheets and those flowing glaciers. Those flowing glaciers flow out to the coast. They hit mountains there where they're stalled. The surface is ablated away. The meteorites that they carry are basically come up to the surface like a lag deposit. So we go to these blue ice areas where these deep blue ice is exposed in Antarctica, and we hunt for meteorites. There's someone collecting a meteorite on the vast expanse of blue ice in Antarctica. Our search techniques are really visual. It turns out the human eye is really good at spotting dark rocks on a light background, and that's the thing. And then it's also very good if you have to search through a moraine and find meteorites, and that's where you're looking through literally millions of terrestrial rocks and trying to find the odd meteorite. Okay, that was pretty quick. Anyway, so we go to Antarctica for a couple months every year. We spend 6 weeks out camping in the field and basically hunting and recovering meteorites. Meteorites are mostly from asteroids there on the left. There's a couple pictures of the basic meteorites from asteroids, chondrites, and then there's an iron meteorite on the bottom there. They're basically scientifically valuable because they record processes from the beginning of the solar system. So these are the first solid grains that are 4.5 billion years old. We also have, we get meteorites once in a while if we're lucky from the moon. Those two pictures of meteorites there are 2 out of the 5 pieces of a lunar breccia we found just this last season. So that's pretty exciting. They're pretty rare. And then we have meteorites from Mars also. So these samples are not owned by myself or even our institutions. They're collected for the U.S. program. The initial curation of these samples is done by the Smithsonian and Johnson Space Center, and then they're actually released and made available for anybody in the world to study.